Picture standing on a world the size of Jupiter, 18.5 light-years from Earth. There is no sun overhead, but the entire sky above you is on fire. A dome of red light, brighter than any aurora over Earth, surrounds you in every direction. Astronomers call this place LSR J1835+3259. It is a brown dwarf, a massive cloud of gas lacking the mass to ignite hydrogen fusion. By the textbook, this object should quietly cool off in the dark over billions of years. This chart shows the energy output of our local auroras. Earth's northern lights release about 100 gigawatts of power. Jupiter produces 10 terawatts. But the aurora on LSR J1835 is 10,000 to 100,000 times more powerful than Jupiter's peak output. That raises an immediate problem. On Earth, our magnetosphere catches solar wind from the sun, funnels them to the poles, and the atmosphere lights up. This object has no parent star to provide that wind. It sits completely alone in space. What we are looking at is a permanent, continuous solar storm, operating entirely without a sun. The trail to figure out how this works started in 2006. Astronomer Greg Hallinan was looking at a few brown dwarfs with the Very Large Array in New Mexico, and he noticed sharp, periodic bursts of radio waves coming from these supposedly dead objects. That specific pulsing signal looked uncannily like the radio broadcasts emitted by the auroras over Jupiter's polar regions. Over the next decade, Hallinan's team chased that signal. By pointing telescopes in California and Hawaii at LSR J1835, watching across visible and infrared light at the same time, they confirmed it. Charged particles were spiraling down and crashing into the upper atmosphere, creating the first confirmed aurora outside our solar system. Then, in 2023, linked radio telescopes resolved the actual shape of the emission. They found a double-lobed cloud of high-energy electrons hanging in space right outside the brown dwarf's atmosphere. The trapped particles reside carry energies of about 15 million electron volts. This seemingly inert object had been wearing a massive, highly structured magnetosphere the entire time. But LSR J1835 is relatively warm from its own birth. In 2024, astronomers found W1935. It is 47 light-years away, and its temperature is around 400 degrees Fahrenheit. For a brown dwarf, that is freezing, far too cold to generate its own aurora. But when the James Webb Space Telescope looked at it, the methane in its atmosphere was doing the exact opposite of what it should in cold air. Instead of absorbing infrared light, the methane was glowing. This diagram shows a temperature inversion. To make methane glow in a frozen atmosphere, something has to be violently heating the very top layer, making it about 300 Kelvin warmer than the air beneath it. So where is the energy coming from? Right now, the leading hypothesis is a hidden, geologically active moon, something like a tiny Io hurling volcanic material into the brown dwarf's magnetic field. We are now seriously hunting for active satellite systems, operating out in the freezing dark, light-years away from any parent star. Tracking down these hidden systems solves a major practical problem for astronomers. We want to study exoplanet atmospheres outside our solar system, but direct observation is exceptionally difficult. Exoplanets are drowned out by their parent stars, their weather showing up as mere faint shadows. Brown dwarfs offer the exact same planetary physics, the same weather and magnetic interiors, holding still in the dark without a host star's interference. Every time we measure the pressure, record the precise temperature, or map the magnetic field of one of these isolated objects, we are observing a pristine laboratory. It is a chance to read the physics of distant worlds under extreme conditions we cannot reproduce on Earth. Calling these objects failed stars carries a heavy judgment. It implies they tried to be something and couldn't quite make it. But they didn't fail. They succeeded at being an entirely unique class of celestial body. They hold the intense magnetism of a giant planet. They boast a lifespan that will outlast entire galaxies, and they wear a glowing red crown. And the data suggests this heating process is incredibly common. There are likely thousands of these dim worlds sitting just outside our stellar neighborhood, quietly running their own weather systems. The seemingly empty, dark spaces between the stars are not void of activity. They are filled with working, glowing worlds, writing their own histories in the dark.